Hey, in this video we're going to graph transformed exponential functions. You should already be familiar with parent exponential functions and basic transformations, but I'll do a quick review of those now. So parent exponential functions look like y equals, let's say, some number a to the x power. A has to be a positive number, not 0 or negative. And there's a couple different cases as to what this parent function can look like. If that base is greater than 1, then the parent function is going to go through the ordered pair 0, 1 and have an asymptote on the x-axis where y equals 0, and it will grow exponentially to the right and shrink exponentially to the left, approaching that asymptote. If the base is less than 1, but still positive, still bigger than 0, well, it's still going to go through the ordered pair 0, 1 because the number to the 0 power is 1. And it's still going to have an asymptote at y equals 0, but it's going to grow exponentially to the left and shrink exponentially to the right. And you can see that pretty easily if you look at particular values of the base a. Now, let's review transformations. We have y transformations occur from arithmetic outside of the parent function, and the order and the operations are what you expect. Again, you should already be familiar with this. This is a quick rundown of, or quick summary. X transformations, however, it's arithmetic inside the parent operation. And that's because that's where x is. So for exponential functions, x is in the exponent, so you're going to find your x transformations in the exponent with x. So that's inside the function. The order, this is the tricky part, the order and the operations here are inverse of what you expect. Okay, so let's jump in and see how we can apply all of this to graph transformed exponential functions. All right, so we've got the function f of x equals 3 minus 2 to the x power. We want to graph that using its parent and transformations. Well, the parent here is not negative 2 to the x. In fact, before we look at the parent, let's rewrite our function a little bit differently so that it's easier to recognize the transformations. This is 2 to the x multiplied by that negative 1 and then adding 3, because the 3 here is positive, so it's like adding 3. This helps a lot. We can see now that our parent is y equals 2 to the x. This negative is a transformation. And so if I want to graph this using the transformations, I'm going to start with the graph of my parent function, or the xy table of my parent function, and I know if x is 0, y is 1. That's sort of our reference point for all these exponential functions. And then I can plug in values bigger than 0. I could keep going. I can plug in values smaller than 0 and keep going and get 1/2 and 1/4. And now I've got my parent graph, or my parent xy table. Then I have to identify my transformations. Well, this guy, if I look at x, there's nothing happening to x. So there are no x transformations. But if I look outside of 2 to the x, I can see multiplication by negative 1 and add 3. So multiplication by -1, that's a reflection over the x-axis if I multiply y by -1. And then the +3 is a shift up 3 units. Well, what I need to do is apply these in this order to my table. So I'll go to my y column and I'll multiply these guys by -1 and generate a new xy table. So notice all my y values have been multiplied by -1. And now something I forgot to point out here, you want to keep track of your asymptote, which initially is y equals 0. And when I'm putting that in the y column because it's y equals 0. When I multiply that by -1, it doesn't change. So my asymptote is still y equals 0 after this first y transformation. But then I go and I apply the +3 operation to my y values and generate a new xy table. And now we can see, after adding 3 to all my y values, including my asymptote, that my graph has shifted, including the asymptote. This is the xy table for the function that I want, after I've applied all my transformations to my parent. Let's go ahead and graph this. I've got my grid turned on. I can see that my graph has an asymptote at y equals 3 and my y values are less than that, so I'll construct my x and y axes in such a way that y equals 3. So here's y equals 1, 2, 3. Here's my asymptote. And my graph will occur below this. My reference point is now 0, 2, which is right here. And I'll plot points to the right. So the order pair 1, 1 is right there. 2, -1 is down here. Now let's plot to the other side. -1, 2.5 is up here, and -2, 2 3/4 is even closer to the asymptote. So we can see we have this exponential growth in the negative direction on this side and exponentially shrinking towards the asymptote on this side. And that's a great first example. Let's try another one. Now we want to graph f of x equals 3 to the power of 4 plus x over 2. So we want to identify the parent, which in this case would be y equals 3 to the x. And then everything here is happening to x. There's nothing happening outside of the 3 to the power. So there are no y transformations. No y transformations. As for the x transformations, the operations we see happening to x are dividing by 2 to x and then adding 4 in that order. We have to inverse those operations and inverse their order to get the x transformations. So our first x transformation is actually going to be the inverse operation of plus, which is -4, which means shift left 4 units. And my second x transformation will be the inverse of divide by 2, which is times by 2, which is a stretch in the x direction, horizontal stretch by a factor of 2. Now I need to generate my parent graph and do these two transformations in this order. Well, rather than graph, I'll just use a table to keep track. And again, I'll plug in 0, 1 as my reference point. Of course, I have an asymptote of y equals 0. These two things are true for every parent exponential function. And then I can plug in positive x values to get 3 and 9, and negative x values to get reciprocals 1/3 and 1/9. And then I've got something to go on here. I can do more points if I want more points, or fewer points if I want fewer points, but I'm putting 2 negatives, 2 positives in my reference point. So I'll go to my x column now for my x transformations, and I'll subtract 4 from all of these. And we can see now that our reference point changed from 0, 1 to -4, 1. Let's change the color of my pen. It's because it shifted left 4 units. My y column didn't change, just my x column. Now I need to do my second x transformation, which is times by 2 to my x column. They're all going to double, giving us a new xy table. Now we can see that our reference point is -8, 1, and I noticed something here during the break. I forgot previously to subtract my 4 from my 1 and 2, so I changed these values to -3 and -2 appropriately, and then I multiplied those by 2 to get the correct x values here in the end. Now that I've done all my transformations to my parent, this is the xy table for the function that I want. Let's go ahead and graph. Now in this case, I've got a bunch of negative x values, so I'm going to put my y-axis way over here to the right. My y values range from positive numbers up, so I'm going to put my x-axis down here. In fact, that's going to be my asymptote is going to be y equals 0, which is the x-axis. My reference point is -8, 1, so -1, 2, 3, 4, 5, 6, 7, 8. Here's -8, let's say. And 1 is right here, so -8, 1 is my reference point. Let's plot -6, 3. So -6 is here, 1, 2, 3 is up there. -4, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 is up here. This is clearly the growth side of the curve. Now we need to plot the two guys to the other side. So -10 is over here, 1/3 is small, and then -12, 1/9 is even smaller. And so this is obviously the side of the graph that shrinks toward the asymptote. And this is the graph of our transformed function. You can see how it's been stretched. All these points are 2 units apart horizontally now because the graph has been stretched. And we've got the shift left of 4. But when you double that, when it stretches, that -4 stretches out to be -8. Okay, let's try another. Now we're going to mix some together with x and y transformations. And here we have f of x equals 1/2 raised to the -x minus 6. The parent, of course, is y equals 1/2 to the x power. And we have an operation on x and we have an operation outside of that. So we have an x transformation and a y transformation. So let's look at the x transformation first. We see multiplication by -1, but we have to inverse that operation. It's the only one. There's no order. The inverse of multiplication is division, which happens to be the same thing, but beside the point, divide by -1. And if you divide x values by -1, that reflects over the y-axis. The y transformations are easier. They're just what you see, which is just -6, which when you subtract 6 from y, that shifts down 6 units. Okay. So we need to generate our parent graph and do these two transformations. Now the nice thing when you have x and y transformations is you can work on the x column at the same time that you work on the y column because they're independent. But I need to generate my parent table first. When x is 0, y is 1, of course it is, and we know that we'll have an asymptote at y equals 0. Put that in the y column. And then I'll plug in +1 for x, which gives me 1/2 to the first, so y is 1/2. Plug in +2 for x, 1/2 to the second power is 1/4. Then we'll plug in -1 and get the reciprocal 2, and -2 and get the reciprocal 4. Now we can apply our transformations. So I'm going to go to the x column, and I'm going to divide the x column values by -1. And I'll go to my y column and I will subtract 6. And in one step, I'm going to knock out both of those transformations to generate our final xy table. We can see our reference point now is 0, -5, and our asymptote is y equals -6. Let's go ahead and graph this. When I set up my graph, I can see my y values are -6 and higher. And my x values are kind of symmetric, so I'll put my y-axis kind of in the middle, and my y values are -6 and higher, so I'll make sure my x-axis is up here. And then I'll go locate -6 on the y-axis, so -1, 2, 3, 4, 5, 6. So here's -6. I can draw my asymptote there. My reference point is 0, -5, and then I'll graph each side of that. I like the whole numbers first, or the integers first. If x is 1, y is -4, so 1, 2, 3, 4. If x is 2, y is -2, that's here. This is clearly the growth side of this curve. Then I'll plot the other side, -1, -5, -5.5, -2, -5 and 3/4 is even closer to the asymptote here. And so this is the side that's getting close to the asymptote. And there we have it. That's the graph of this transformed function with a base that's less than 1, an x transformation, and a y transformation. Let's do one more example. All right, here we want to graph f of x equals -4 to the -x plus 1 plus 7. So we're going to have, with x, we have two operations. So we're going to have two x transformations. We have two operations outside of 4 to the power. So we're going to have two y transformations also. So our parent function is just y equals +4 to the x. Our x transformations, we can see multiplication by -1 and then add 1, but we need to inverse those. So our first guy here is going to be to subtract 1, which means shift left 1 unit. And then I need to divide by -1, which is a reflection over the y-axis. My y transformations are, as you see, multiply by this -1 and add 7. In that order. So multiplying y by -1 reflects it over the x-axis. So we've got a couple reflections here. Adding 7 shifts it up 7 units. Let's get to work. We'll generate our parent function. I'll do that with an xy table. Starting with the reference point. And I want to make sure I don't forget my asymptote. It's easy to forget that. Now I need to go work on my x column and my y column because I have both transformations. So my first x transformation is to subtract 1, and my first y transformation is to multiply by -1. And we get a new reference point, -1, -1, and the asymptote didn't change because if you multiply 0 by -1, it stays the same. Now let's divide my x values by -1, and let's add 7 to the y values. We get a new reference point at 1, 6 and a new asymptote at y equals 7. And this is our final XY table, so we can plot these points and we'll have the graph we're looking for. We can see that our graph occurs below y equals 7, and our x values aren't too bad, so I'll put my y-axis kind of in the middle here. And then I need to be able to access y equals 7, so I'll put my x-axis a bit lower. 1, 2, 3, 4, 5, 6, 7 is right there. Graph the asymptote. Let's plot our reference point at 1, 6, right here. And then let's plot the integer points. So 0, 3 is up here, and -1, -9 is way down there. This is our growth side. It's growing really pretty rapidly. Plotting points on the other side at 2, 6 and 3/4, that's getting close to our asymptote. And then 3, 15/16 is even closer. Or sorry, 6 and 15/16 is even closer. So this is our shrinking side. And there we go. We have the final graph of this transformed exponential function with two x transformations and two y transformations. It may feel a bit tedious, but this is about worst case scenario where you've got all these transformations. It's just arithmetic, and it's pretty basic, and it works the same on every single parent function. So good luck with your exponential transformations. I hope this made sense, and I'll see you soon.